Yes, hi guys. Now I'm taking the basics of trigonometry. In this lecture, this lecture number 4 series. Okay, I'm taking the basics. Now this question, or these questions or this lecture series, I had to take in the beginning, but now I'm taking. The reason is that I have talked about the four quadrants in the previous lecture series, 1, 2, 3. Now in the fourth lecture series, I'm taking the further basics of this. Here the basics, fundamentals or fundamental identities are used here. Sometimes trigonometry, in the trigonometry we use the triangle solution of triangles. This is solution of triangles. With the help of solution of triangles, we can find out what are the trigonometric functions or trigonometric ratios. If one trigonometric function is given, then find out what are the other 5 trigonometric functions or ratios. Functions or ratios are just pronounced vice versa. Either I'll pronounce it as functions. I will say either functions or ratios. Both are same thing. Okay, so ratios or functions, trigonometric ratios or trigonometric functions. So the value of the trigonometric function, we have to find out if one trigonometric function, a particular trigonometric function in a particular quadrant is given. Then what are the conditions? I've talked about that we have to use regarding the signs of the trigonometric functions in different quadrants. All students took coffee. This I've talked in third lecture series and second also. Okay, so in the previous lecture series I've talked about all this. All the students took coffee. All are positive in the first quadrant. In the second, sign, all the students as for sign and cosec are positive. And in the third one, took coffee. Took means tan theta and T for tan theta. Tan theta and cos theta, both are reciprocal of each other, are positive in the third quadrant. In the fourth quadrant, coffee. All the students took coffee. C for cos theta and second theta. These are reciprocal of each other. Okay, so because of that, the fourth quadrant, cos theta and second theta are positive. Others are negative. So this is regarding the quadrants. Now this value of quadrants, of the trigonometric functions in the different quadrants, is to be used to find out what are the values of, if one trigonometric function is given, the value of one trigonometric function is given in terms of sides, then what are the other sides of the triangle, okay, and what are the trigonometric functions in those sides, okay, that we can find out. Now in this case, I'll apply the two methods. What are those two methods? Let me talk about. First of all, if one trigonometric function is given, okay, the value of one trigonometric function is given, then we have to find out the other trigonometric function. For that, there are two methods. First of all, either we use a right angle triangle. Draw a right angle triangle. If theta is given, suppose this is theta angle, and let me take ABC, a right angle triangle. This is a right angle triangle. We deal with trigonometry or trigonometric functions are described in right angle triangle. So the side opposite to the theta angle is perpendicular. The right angle opposite to the right angle opposite to this is hypotenuse. We denote it by H. And other side, the third one is base. Okay, so this is base. This is perpendicular. Okay, and this is hypotenuse. These are by Pythagoras theorem we know what. With the help of Pythagoras theorem also we can find out what is the process of this, and all those fundamental identities I described in the first lecture series, in which I talked about what the fundamental identities. There were 9 fundamental identities. So if one trigonometric function is given, and either use these sides of the triangle. If suppose sin theta is given, suppose there is 3 by 5 or 4 by 5, whatever. 3 is the base, perpendicular here, side opposite to theta angle. 3 is this, and H, hypotenuse, is 5. The other side, 4, can be calculated by Pythagoras theorem. With that, H square is equal to B square plus B square. The square of the hypotenuse is equal to sum of the squares of the other two sides. In this way, this is nothing but 3 square. This base is not given. So B square plus 3 square equal to 5 square. B square is equal to 25 minus 9 equal to 16. B is equal to plus minus 4. Square root of 16. we have to take it as that 4, positive 4 value, because sides of the triangle are positive always. This is plus 4 here. So plus 4 is the base in this case. So other sides can be calculated by the formula PBP divided by HHB. PBP divided by HHB. This is one of the process. Okay, one method is this: either use the triangles and the other sides are calculated. One leftover side is calculated with the help of that trigonometric function which is given. Okay, two sides will be given there because the value of one trigonometric ratio is in two sides of the triangle, in terms of two sides of the triangle, the ratio of two sides of the triangle. So with the help of those two sides we can find out the other third side. In this way third side is calculated here. This is one process. Now other trigonometric ratios can be calculated. P upon H is sin theta, P upon H is cos theta, P upon P is tan theta. Okay, this formula is to be remembered by P upon H B, P upon B, P upon H, perpendicular upon hypotenuse is sin theta, base upon hypotenuse is cos theta, P upon P, perpendicular upon base is tan theta. So, and the others are reciprocal of these. Cosec theta, reciprocal of sin theta, sec theta, reciprocal of cos theta, cos theta, reciprocal of tan theta. That will be cosec theta is H upon P, sec theta is H upon B, and cos theta is B upon P, base upon perpendicular cos theta is. So in this way, other sides, other trigonometric functions can be calculated. This is one of the processes. This is the first process I'll talk about. Second process. What is second method or second process? Second method is if suppose sin theta is given, as I take example, sin theta, for instance, sin theta is 3 by 5 given to us. Now we have to find out what are the other. If I'm able to find out sin theta and cos theta, only the two trigonometric functions, then others can be calculated easily. How? Let me apply this method also. This is suppose sin theta is given. What is cos theta? We know about one trigonometric identity. The fundamental basic identity is sin square theta plus cos square theta is equal to 1. Alright. If in any quadrant it is given, the value will be negative, positive, that doesn't matter, but sides are given here, 3 and 5. So here cos theta is not given, so cos square theta is equal to 1 minus sin square theta given to us. Now 1 minus sin square theta is 9 by 25. It is nothing but 25 minus 9 is 16 by 25. Therefore cos theta is equal to square root of the 16 by 25. That means plus minus 4 by 5. Okay, so plus 4 by 5 or minus 4 by 5, that will depend upon this. We always take the plus 4 by 5, but according to the quadrants, the signs of the trigonometric function will be changed. To that we will put here. Suppose it is negative, we will put it as minus 4 by 5. If it is in second quadrant, third quadrant, okay, then cos theta is negative, so it will be then minus 4 by 5. But sin theta is positive in second quadrant, in first quadrant, in third and fourth sign is negative. In that way, negative sign will be kept. Only the sides cannot be changed. Sides will be the same. Value of the sides will be, length of the sides will be same. This is another process. Now, with the help of sin and cos, for example, tan theta, we know about tan theta is equal to sin theta upon cos theta. Sin theta upon cos theta. So sin is P upon H. Cos theta is B upon H. H is cancelled out. This is P upon P. P upon P last from tan theta. This is tan theta here. So in this way, whatever the value of sin theta is there, that will be divided by value of cos theta, which we have calculated here. Tan theta is calculated. Okay, so others are reciprocal of these three. So cosec theta is reciprocal of sin theta. So whatever value of sin theta is given, 3 by 5, cosec theta will be 5 by 3. Okay, and second theta will be 5 by 4 because reciprocal of cos theta. In this way, this is calculated. And cot theta is reciprocal of tan theta. So this is here. It is now. Yes, what are the values here? P upon B. P upon B is 3 by 4. This is 3 by 4 here. Sine is 3 upon 5, cos is 4 by 5, 5 factorial not 3 by 4. It is 3 by 4, therefore cot theta is 4 by 3. All the 6 now trigonometric functions are known. So this is another method. Whatever method we apply, answer must be the same, or answer will be the same. That is the process. And these two methods, either of them can be applied to find out the value of the other trigonometric functions. That is the formula. Okay, so these two methods, either of them can be applied. Just to verify if one method is not clear, then other method can be applied to just check the answer. Okay, that is the process and the technique to understand the right correctness of the answer of the question. That is the requirement here. Now let me take these questions one by one. These two methods, either of these two can be applied. Either trigonometric identity we have to use, the basic trigonometric identity, the first one sin square theta plus cos square theta is equal to 1. From that sin theta, if it is given, cos theta is given, we can calculate the other trigonometric functions. If value of tan theta is suppose given, then the tan theta and then secant theta can be calculated. What is tan theta then? We know that 1 plus tan square theta, this is another trigonometric identity, is equal to secant square theta. If secant square theta is equal to 1 plus tan theta, if tan theta is given, then sec square theta, sec theta can be calculated from this function. Sec theta is calculated, cos theta is known, tan theta is calculated, cot theta is known. Okay, so tan, cot, and secant and cos, these four are known. Sin theta is, then sin theta can be calculated. Now sin theta is, with the help of cot theta we can calculate that. Okay, so what is that? Or if cos theta is calculated, then sin theta is 1 plus sin, 1 plus, sorry, we can take it as 1 minus cos square theta or sin square theta equal to cos square theta, or 1 minus cos square theta is equal to sin square theta, or sin theta is equal to plus minus under root 1 minus cos square theta. If cos square theta is known from this sec theta is 1 upon cos theta, or cos theta is 1 upon sec theta, the cos theta will be known. With the help of this formula, basic fundamental theorem, basic fundamental formula identity, we can calculate the value of sin theta. Sin theta is known, then cos theta is also known. I mean, either of the trick can be used, either of the techniques can be used. One technique is that use the fundamental identities. Second method is use the right angle triangle, with the help of that find the sides. If sides are known, then other trigonometric functions can be easily understood. These are two methods here. I have described them again and again. Now I have to apply them in solving these questions. These questions again I just collected from the student side. Number of questions are there still, which I cannot take. I have taken these 16 questions here, and the method of this writing questions here, which are very briefly written, is this, that I am not to check the notes, or I am not to keep a notebook in my hand. So my two hands are free. Now I'll take every question by pronouncing every question in words, writing questions here also, so that one can understand that what are these questions given to us. If they are not visible, I mean, even if they are not highlighted, for example, some students complain that some questions are not highlighted, but I'm writing every question here, so that this is easier for me just to understand that what questions are there. Because in checking the notes, again taking notes, that is not a proper thing, I consider. But if I take the notes here, then I'm writing one question, solving one question. But for those students who want to just check the questions of mine, if they can highlight these questions, can understand the questions, then I have noted down these questions, they can solve them, or always. So this is the process of telling the student these questions. Okay, writing these questions here on the board. Yeah, I'm taking one question, every question. First writing the question, okay, and just reading the question what is given to us and writing here, and then solving the question. So that makes two purposes solved. What are the two purposes? That the students can understand that what are the questions given to us. If there is any mistake, I will come to know that what is the mistake here. Second is that every question is taking less time than, because it is written there. Now question is first. Let me take first question here. what are the methods? The two methods I have already described, that either of the methods can be used. First is if sin theta is 3 by 5. Okay, the same question is given to us. Okay, if sin theta we are given here is equal to 3 upon 5. Alright. And the theta lies in the second quadrant. It says the theta lies in the second quadrant. Theta is here lying in the second quadrant. Suppose this is theta here. This is the process. If theta lies in the second quadrant, then we know that in the second quadrant sin theta and cosec theta are positive. Only sin and cosec, the reciprocal of each other. Sin and cosec. These two are positive. Others are negative in second quadrant. So if I take other trigonometric functions like cos theta, that will be negative. First and foremost thing is that we have to find out what are the values of those functions. Then negative sign can be kept with other trigonometric functions other than these two, because in the second quadrant we know that all students took coffee. All students will sin theta, S for sin theta, and cosec, which are reciprocal of each other. These two are only positive. Other four are negative. That is the point. Sin theta is given to us this. Now find the following trigonometric ratios. So sin theta is this, then theta lies in the second quadrant, then find the other 5 trigonometric functions or ratios. Okay, this is the point here. For the question here, if sin theta is 3 upon 5, theta lies in the second quadrant, then find the other 5 trigonometric functions or ratios. That's the point here. Okay, that I read. The question is this. So here sin theta is given. Now let me find the solution. Both the methods are to apply. What are the two methods? Either apply the formula, trigonometric identity, or apply the triangle. Okay. If I just frame a right angle triangle, as I tell you, this is theta here. Let me take ABC. Okay, ABC is the right angle triangle, and this is H here. Sin theta is perpendicular is the side which is opposite to the angle, which angle is considered at the time of calculation. Here we are calculating this theta angle. The sin theta is equal to what? If the theta is here, this angle is considered, and the side opposite to this is perpendicular, this P is perpendicular. The side opposite to 90 degree is always hypotenuse, no change, and the other is the base, B, we have taken. So by Pythagoras theorem, we know what is this h square equal to. H is given, this is P equal to 3 here, and h equal to 5. So tan theta is equal to 3 upon 5 we are given. The other side is 4, we know that, because b square, the other side is h square minus p square. By Pythagoras theorem, h square equal to b square plus p square I just described. So therefore b is equal to under root of h square minus p square. That means square root of 25, h is 5 here, this h is 5 here, 25, h square is 25 here, and p square is 9. Okay, so this is 16 is equal to plus 4. I have to take plus minus 4 or plus 4 we take, because length of the sides are always positive, sides of the triangle are positive always, not negative. This is plus 4 here. This b equal to 4 we have calculated. Other trigonometric functions can be easily calculated with the help of this. What is cosec theta? Cosec theta is just opposite of sin theta. So this is 5 by 3. Just reciprocal of sin theta. Sin theta is 3 by 5, it will be 5 by 3. Now what is cos theta then? Cos theta is b upon h. Cos theta p upon h b. There are 3 very important ratios we have to understand. First is sin theta, cos theta, tan theta. So cos theta is b upon h. B is 4. It is 4 by 5. But it says theta lies in the second quadrant. If theta lies in the second quadrant, cos is negative, so it is minus 4 by 5. Just we put minus 4 by 5. Some important point. Why? Because theta, it is given that theta lies in the second quadrant. It says theta lies in the second quadrant. Second quadrant, let me write. Second quadrant. Quadrant means this 1.4 part, 1.4, 1.4, 1.4, 1.4. We divided the plane into 4 parts. This is first quadrant, second quadrant, third quadrant, fourth quadrant. Okay. Quadrant means 1/4. So these 4 parts are equal of 90 degree each. 90 degree, 90 degree, 90 degree, 90 degree. So 360 degree divided into 4 parts. Alright, so this plane is divided into 4 parts. This is the second part. In the second part, sine is negative. Sorry, sine is positive and cosec is positive, are positive. These two are positive. Cos theta and other, 4. Cos theta, sec theta, tan theta, cos theta are negative. This is minus 4/5 cos theta. Now what are the other? Now with the help of this sides I am calculating. P upon V is tan theta. Tan theta is also negative. It will be minus 3/4. Simple. Cos theta is also negative. It is 4/3 minus sine. And secant theta, which is also negative, it is minus 5/4. We always keep minus sign in the numerator, not in the denominator. It is minus 4/3, minus 3/4. These are the other 5 trigonometric ratios with negative sign. So this is with the help of right angle triangle. Okay, now if I have to calculate this with the help of trigonometric identity, which is the basic trigonometric identity. What is that? We know that sine square theta plus cos square theta is equal to 1. This I've talked about in first lecture series. You see there. How did we calculate this? So sine square theta plus cos square theta equal to 1. Sin theta is given, so cos square theta is equal to 1 minus sine square theta. Takes sine square theta to that side. It will be 1 minus sine square theta. Therefore, cos theta is equal to plus minus is equal to cos 1 minus sine square theta. Now, cos theta is negative in the second part. So we can keep here minus sine. This is minus sine is square root of whatever value comes out to be. This is 1 minus sine square theta. Sin theta is 3/5. So it will be 3/5 whole cube. So it is minus sine because cos is negative. That's why I have taken negative sign here. Minus sine cos value will be negative. What is that? This is 25, 9 upon 25, 25 will be here upon 9. Okay, minus 9 upon 25. It is nothing but square root minus sine 16/25. It is minus 4/5. Minus 4/5 is the value of cos theta here. So cos theta is calculated. Cos theta is minus 4/5. What is tan theta then? Tan theta we know that it is sin theta and cos theta. Now sin theta is positive, which is 3/5. Cos theta is negative, which is minus 4/5. So finally it will be 5/5 cancelled out. So we can write as 3/4 into 5/3. Sorry, 5/4 with minus sign here. Let me write minus sign here. So this 3/5 it is. So 5/5 cancelled out. It is minus 3/4. It is tan theta. Tan theta is minus 3/4. We could write here 5/5 cancelled out. Minus 3/4 here. Directly we can calculate. So 5/5 cancelled out. Minus 3/4 is the value of tan theta. Now others are reciprocal of these. Now cosec theta is a reciprocal of sin theta, so it is 3/5 is sin theta, so it will be 5/3. Now cos theta is minus 4/5. Secant theta will be minus 5/4. This reciprocal of this reversed 1 upon this value will be reversed, and cot theta is equal to, this is tan theta is minus 3/4, it will be minus 4/3. Simple. So all the other five trigonometric ratios are calculated. Just you have to keep in mind that what is the negative sign or positive sign. What are the trigonometric functions, in which quadrant they are lying. So the value will be accordingly negative or positive. So it's according to the quadrant here. This is question number 1. Similarly, question number second Question number 2, I need a second question, and others can be calculated. Let me just check what is the question number 2. Now question number 2 says cos theta is, question number 2 says cos theta is equal to minus 1.2. Alright. Theta lies in the third quadrant. Alright. Theta lies in the third quadrant. This is the third quadrant here. Now in the third quadrant, tan theta, tan and cot, which are reciprocal of each other, are positive. They are positive here. Others are negative. Tan theta and cot theta. All students took coffee. Here coffee. And here took T for tan theta. And all students. And S for sin theta here. Sin and cos. Sin and cos sec are reciprocal of each other. And here it is always all the 6 trigonometric functions are positive in the first quadrant. First quadrant, all students took coffee. This is the basic criteria here. Okay, now let me talk about what are the values then. So here it says that theta lies in the third quadrant. Theta lies in the third quadrant. It says, then find the other 5 trigonometric functions. If cos theta is equal to minus 1.2, theta lies in the third quadrant, then find the other 5 trigonometric functions. That's the question here. Okay, so just I'll recite or read every question, and after that I will do this so that one can understand what is the question here. Question is that if cos theta is minus 1.2, negative value of cos theta, so theta lies in the third quadrant, it says. Either theta lies in the second or third, but it is given here that theta lies in the third quadrant, which cos theta is negative in second and third. So it is lying in the third quadrant. Alright, so in third quadrant, tan will be positive, cot will be positive, sin, cosec, cos and sec, these 4 will be negative. Okay. Now cos theta is given to us. So either a right angle triangle, draw the right angle triangle here. Put the values. This is theta here, perpendicular, H, right angle triangle. This is B here. Now cos theta is B upon H. B is 1, H is 2. Negative triangle, we think about other triangle. So this B, second side is calculated by subtracting the square of the other side from the hypotenuse square. H square minus B square. H square is 2 square, that means 4. B square is 1 square, that means 1. That means 3. So P is equal to plus minus under root 3 dot is equal to plus 3 we have taken. Reason is sides are positive. Now P is, we have calculated root 3. So others ratios can be calculated with the help of the right angle triangle. This is ABC. Okay, so others are cos theta now. Sorry, cos theta given, sin theta. Sin theta is P upon this. Therefore, sin theta is root 3 by 2. Now in the third quadrant, sin is also negative. This is negative here. We keep negative sign. Sin is negative. Now sin is calculated. Tan theta and others can also be calculated. Tan theta then, what is tan theta? Tan theta is positive. It will be positive. Either put sin theta upon cos theta, that will give us a tan theta. Or we just put the sides here. So what is the tan theta here? Tan theta is B upon B. B upon B root 3 by 1. That means root 3 only. Positive value. This is calculated. Or we can calculate tan theta is equal to sin theta upon cos theta. Now sin theta and cos theta both are negative in third quadrant. The values are these. Now sin theta is minus root 3 by 2 and cos theta is minus 1.2. If you cancel out minus plus, it is root 3. Okay, so tan theta is root 3. Same thing. Others are reciprocal functions. We can calculate others also. What is cosec theta then? Now cosec theta is reverse of sin theta. That means minus 2 upon root 3. What is secant theta? Reverse of cos theta, that means minus 2 upon 1, that means minus 2 only. This is minus 1.2 cos theta, reverse of reciprocal of sec theta. So sec theta is reciprocal of cos theta, that means sec theta equal to 1 upon cos, that means minus 2. And cos theta left over. So cos theta is reverse of tan theta, that means 1 upon root 3. This is root 3 is a positive value. So cos theta is also positive. Cos theta, tan theta are positive in the third column. So these are the values. Other values are cosec theta, sec theta minus 2, cos theta 1 upon root 3, cosec theta minus 2 upon root 3, tan theta is root 3. Okay, sin theta is minus root 3 by 2. This is the first required ratio. This is the second required ratio. This is the fourth, third one. This is the fourth one, and this is the fifth one. These are the five trigonometric ratios which were required. This is the process. Either use this process or with the help of fundamental identity, which is of sin theta cos theta. So what is that? That can also give the same answer. What is that? Cos theta. That we write here sin theta. In this case, sin theta we have to calculate. Sin square theta plus cos square theta equal to 1. Cos square theta is given. Okay, so sin theta we have to calculate. So sin square theta is equal to 1 minus cos square theta. Now cos sin theta is equal to under root plus minus sin here 1 minus cos square theta. And this is 1 minus 1 upon 4. Right? But minus 1.2 whole square, right? Cos theta is minus 1.2 whole square. It will give us 1 minus 1.4. That means square root of 4 minus 1 upon 4. That means under root 3 by 4. That means root 3 by 2. This is cos theta, this is sin theta here. But sin theta is negative because it's the third quadrant. So let me keep here minus sign, minus sign, minus sign. So this is minus sign here. Minus root 3 by 2. So minus root 3 by 2 is the value of sin theta in this case. Now sin is calculated, cos is calculated, tan theta can be calculated by sin theta upon cos theta. Therefore, tan theta is equal to sin theta upon cos theta. These are negative, minus root 3 by 2 upon minus 1.2. This is cancelled out. This minus plus root 3 on this positive value. Okay, tan theta, sin theta, cos theta. All three are calculated. Others are reciprocal. Other three